What's up guys, it's Saad here, and for the past week and a half, I've been working on this machine learning driven web app that takes as input any sort of text you want to give it and tries to predict the emotions that are present in that text. So I actually came up with this idea while doing schoolwork using apps like Grammarly and Google Docs, and I was pretty interested in how they were able to extract so much information from the text that you were giving them. And I started wondering what kind of machine learning algorithms were working on the back end in order to achieve this feature. So that got me thinking, I could probably make something like this on a smaller scale, albeit, that would perform pretty much the same function. Now, maybe it can't predict where the grammar is going wrong in your text, but it might be able to predict the tone and emotions inside your text. So I decided it would be a fun idea to make a full stack application that could do some sort of analysis on text. So in this video, I'll be guiding you through the development process, the challenges that I faced, as well as the final product and how I could have made it better. So without any further intro, let's get right into it. Okay, so we're on to the first step of the development process, which is training the NLP model. So I'm using NLTK, TensorFlow, and scikit-learn for this. And I'm also using a dataset that I found on Kaggle. Link is going to be in the description below. And essentially it has 16,000 different text samples, along with I think 6 different classes that they map to. So this is going to be a multi-class classification where the 6 classes represent different emotions that each text sample can belong to. So the first thing that I did when pre-processing this data is cleaning the features. This is pretty much a mandatory step. We just remove the white spaces, so any trailing white space or non-alphabetical characters are just going to be replaced with a single space, as well as putting the sentence in lowercase because we don't want any difference in capitalization to impact the accuracy of the model. So we're just going to interpret all these sentences as lowercase. And we're also going to perform lemmatization on each word in the sentence. So we want to reduce each word to its stem, to its root word pretty much. And that's what lemmatization does. So for example, the word having would be reduced to the word have, which keeps most of the meaning, but it reduces the amount of words that the model has to learn substantially. So this reduces dimensionality and just makes our model have to learn less unique words, which makes it more accurate. And we also just convert the sentence back into a string, and this becomes our new training X data. So we've cleaned out most of the stuff that's gonna, make it more difficult for the model to learn. And now that our data is clean, we can perform something called tokenization, which is essentially assigning a number to each word in each sentence. So the way that works is it looks at all the unique words inside the text corpus or the dataset and assigns them a number. Then each sentence is converted into an array where each element in that array is the number that corresponds to the word that would normally take that position in that sentence. So essentially we're converting string data, which is something that humans could read, into numerical data, which is something that the neural network can process. So TensorFlow makes this really easy with the pre-processing text tokenizer function. So we can fit this on our clean sentences, and then we can use the text to sequences function, which tokenizes this data or creates sequences, like array sequences of numbers. And this becomes our new data. So it's now numerical data. And we're also going to perform something called padding. So what padding is, it essentially it converts all the text data or numerical data now into sentences of the same length. So in order for our neural network to actually process this data, it has to be of the same shape, but not all the sentences in the dataset are the same length. So we choose a length that would incorporate most of the information in that dataset. I chose 150 because I think the 80th percentile of sentence lengths in that dataset was around 135. So I went a bit higher than that just so I could capture most of the information in the data set. So I set the max length to 50. So now any sentence that is longer than 150 words will just be cut off at the 150 mark. And any sentence that is less than 150 words will be padded with zeros, which is a reserved number, because again, we're doing tokenization. So each word is represented by a number, and once there's no more words left, the sentence is just going to be padded with a bunch of zeros until the length is 150. And this other function is just for the testing data. We're not actually going to fit it on the text. We're just going to transform the testing sentences to the tokenized data. So now we can actually train the model. There's a few cleanup things that we need to do. So we need to actually extract our training X and our tokenizer from the function. It's also going to return the tokenizer as well, because we do need to pass that into this other function for the testing set. And we're also going to record the number of words that the tokenizer learned, which is just going to be this length of tokenizer.indexWord, this attribute. The reason we do this is because we actually need this in the embedding layer of our model. And we're also going to encode our labels, because our labels right now are also string data, which the neural network can't really interpret. So we're going to do something called one-hot encoding. So we have 6 different classes in our Y data, or our labels. What that means is we need to make a vector of length 6 such that if one element in that vector is non-zero or 1, that corresponds to a class. So for example, if the first class is the emotion of sadness, then if the first element in that vector is a 1, then it would mean that that label corresponds to sadness. So we're essentially just converting a bunch of unique string data into vectors, where each where we can make the vectors unique so that the neural network can understand the differences between the data. Okay, so now we can actually get to creating our model. So our model is going to be a Keras sequential model, and the layers that we're going to add are the following. So the first layer that we have is an embedding layer, which essentially creates a unique vector for each unique word in the sentence. The reason I chose this is because we're using tokenization, and we can't really pass tokenized data to the neural network without performing some sort of word embedding. The alternative to this would be using word2vec, but I didn't find good results with that. So using this embedding layer was the best option. And we can choose an arbitrary number of output features. I chose 240 just because I didn't want to increase the number of parameters by too much, and I found that 240 was pretty good at preserving most of the meaning behind the data. And we also have to do flattening after this layer because it actually returns a 3-dimensional matrix, which is not what we want. Each time the data is propagated to the next layer, it needs to be a 2-dimensional matrix, just because we have a bunch of dense layers after this. So we need to flatten this into something that we can actually pass into these fully connected layers. And we just have a few dense layers and also a dropout layer, just because I don't want to overfit the data to overfit the model to the specific data set. So I added a dropout layer with a rate of 15%. So just so that 15% of the neurons past this point are essentially going to be shut off during the training phase. So the model doesn't learn to rely too much on certain neuron weights, so that it can adapt better to real-world data, because that's the whole reason that we're making this model, because we want to deploy this on a web app and you can type in your own text and see how it predicts the emotions in that. So we want some sort of regularization to make sure that the model doesn't get too dependent on this data set. And we have our output layer, which is just 6 units because we have 6 classes, and we're using categorical cross entropy as our loss just because we have multiple categories. We're doing multi-class classification. So I think we can start training now. I'm just going to run all the cells. Hopefully I don't get an error. So just going to import the libraries. And okay, so it looks like our model's training right now. Should come up unless I've done something wrong. While this trains, I'm just gonna shut off the camera and I'll get back to you when I see the results. Okay, so now that the model's done training, we can look at some of the sample results that we have. So the way we're gonna get results is we're gonna apply the clean features function to the test set. We're gonna tokenize the test set also. And we're also gonna perform one-hot encoding, just like we did on the training sample, the training features. We're gonna do that to the testing features as well. And I don't know why I just printed the shape here. And we're just gonna pass this to the predict function of the model. And we're gonna have a y truth, which is the ground truth, the actual labels that we had, which is just gonna be np.argmax. So what we're doing here, we're taking the index of the value in this one-hot encoded vector, that is 1. So that index is going to tell us which class it belongs to, which is why we're taking argmax on axis 1, because this is a matrix with each row vector being the one-hot encoded vector, and then each row corresponding to the sample. And we're going to do the same thing for the predictions, which is just going to be the result. Same thing, we're going to call np.argmax. So we're going to see how many times the correct predictions, we're going to see how many times y pred equals y truth. So how many times the predictions equals the truth. And this is going to be a Boolean array of just true and false values. So we can actually take the sum of this because each true and false value can be interpreted as 0 and 1 just by NumPy under the hood. That's why it's so helpful. And we're going to divide this by 1600, which is the amount of testing samples that we have. So, and then we're going to predict the correct, actually have that commented out, but we're printing this sum, which is just the average, and the accuracy is about 83.75%, or about 84%, which is pretty good for the testing set. Of course, it's not as high as the training set because it was able to learn a lot better on the training set, whereas it's never seen the testing set data before. There may be some words in there that it's not seen in the training split, which is fine, but an 83% accuracy is still pretty good. And I defined just this little function to make predictions that I'm going to actually import to the Flask model, but if we want, we can just make a prediction like make pred I had a good day today. This is essentially what's going to occur on the back end, or like this is the main feature of our app that we're going to make. So this is pretty much 80% of the work for the full stack application. So we can just print whatever this is. So I'm going to cut that, put that in a new cell, or made 2 cells by accident. And I'm just going to print the result of this, and I think it's going to be final is going to be emotions of final. So let's see what we get. So we get joy, which is pretty reasonable. Yeah, I think joy is what this would fit into. So far it looks like it's fine. And we're also going to use the pickle module to convert the tokenizer into a binary file, just because we also want the same tokenizer on the back end of our Flask app, because it's already been trained on the words. And this was the most quick way I could find to do it. There's probably a better way, but I haven't gotten into reading the documentation, if I'm being perfectly honest. But since the file isn't too large, I think this works well for now. And now we're just going to move on to the back end of the app, and also a bit of a demo on how it works. So I'll see you in the next part of the video. Okay, so I'm in my VS Code right now, and I have the script running. We're just going to go through the model on the server side, as well as the API, and we're also going to look at the front-end code a little bit. Not going to get into the implementation detail. The source code's going to be linked on my GitHub. So let's get into it. So we have the imported version of the model, and if you can see, we already have a lot of the code from Google Colab, just pretty much copy and pasted here. So we have our imported libraries. So we have NLTK, TensorFlow, and the Lematizer. And I've also imported the emotions array, which is just from the one-hot encoder. Unfortunately, due to some dependency issues, I wasn't actually able to use scikit-learn on this machine specifically, just because I have a Apple Silicon MacBook, and for some reason, the Apple Silicon version of TensorFlow just doesn't want to use the same version of NumPy as scikit-learn, so I just had to copy this array over here rather than actually import the one-hot encoder, which kind of sucked, but everything else still works. So we still have the stop words, and we have lemmatization, so we have the WordNet lemmatizer, and we have the clean features function over here. And we're performing pretty much the same operations to the new testing data that we're going to get that we did on Colab. And we also have the tokenization function, again with the tokenizer object over here. And we also have the create model function. So we do have to do this on the backend once again every time we run the app, but we don't actually have to train it because we have the weights saved over here. So all we have to do is create this model, and I actually have two different architectures that we can use. So this smaller model has much less parameters. It's the one you saw on Google Colab, just because the file sizes for the weights can get pretty big, and after a certain point you can't deploy that to a Heroku server. So I decided to use one with less parameters. So that's the one we're going to use now. So we have a smaller model, and we're just going to load the weights, and then we can use this to make predictions. So we have the make predictions function, again, just from the front end. I mean, from Colab, not the front end. And we can test this out just by running the script. I'm not actually going to do that. I'm just going to show you on the actual application in a second. So we can just make predictions, put in a regular string literal, and it should print the sentiment or the emotion predicted. So that's the model module. The actual Flask app is very simple. There's only one route other than the routes for serving these static files. There's only one route, just /sentiment. We can make a post request where the body only contains one field, which is the text, and we're going to return a JSON object with sentiments, and the value of this is going to be an array of the different emotions, where each value is going to be a floating point number corresponding to the confidence that this emotion is present in the text. So 1 would be 100%, and then 0 would be 0%. So the numbers are between 0 and 1. So this is pretty much it for the front end, and we're just going to run the app on localhost. I do have it running, so I will be getting to showing you the front end, and then at the end of this time I'm just going to show you the React code. Now we're going to look at the actual application. So we have a Draft.js editor here. Didn't make this myself. I used Draft.js to get a nice editor with a bunch of formatting options. Doesn't actually add any functionality, quite frankly, to the prediction, but it looks nice, so I decided to put it in there. And there is the sentiments or the emotions here, along with a confidence bound to see which emotions the model thinks are most prominent in the text. So we can actually just start typing here and see what the model thinks. So I'm just going to try a basic sentence. I had an amazing day today. And let's see what it predicts. So we get surprise and joy. So the reason we probably get surprise is because of amazing. For some reason it may think that it's associated with surprise, but I would put this more with joy. If we try another sentence, like I went to the... So if we try something like that, we get a much better confidence band because there's more words, more adjectives for it to learn from. Just because of the way that the model is made, adjectives and descriptive words are weighted much higher and contribute a lot more to the actual output. So that way, longer sentences, around 50 words, because that's sort of the mean length of the sentences that the model was trained on, work much better. So we can also try and type something without adjectives and see if it can make some sort of relationship between the words and the emotions. So let's try something like I made the basketball team. Okay, and there's no punctuation, of course, and it also predicts joy, but it's not too confident about it. We get a bit of sadness, but we still get that as the overwhelmingly decisive choice. We can try something like, I got a promotion at work. Okay, most of the data was written in first person, so that's what the model works best with. But I did try it with a few excerpts from stories like Shakespeare, and it worked decently well. You guys can try it out. Right now I'm running this on localhost, but you can actually try this on Heroku. I'll have the link in the description, and should also be on my website. You can check it out. And we're getting joy, and we're also getting a little bit of ambiguity here, some indecisiveness with the other emotions, but it's still overwhelmingly joy. So you can play around with this and see what you get. There's some information about me here as well. It's me. And yeah, just check out this app. Source code is also going to be in the description below. In fact, I should probably, let me go back to VS Code here. Should be able to take a quick peek at the source code. So it's written in React, specifically TypeScript, just because TypeScript makes everything a lot better. And see over here, there's not too many components, just the editor, homepage, and the sentiment part. It's a pretty straightforward app. The front end isn't the main component of this, but if you want to see just how I integrated the front end and the back end, you can check this out right here. And I think that's it for the video. If you have any questions, you can always reach out to me. And thanks for watching.